Welcome to section 12.3. This is simplifying rational expressions, and this is the second video we are working with. So in this video, we're going to just do a brief recap of how we can use opposite binomials to solve problems. We already touched on this a little bit in chapter 8, so there is a section based on this already. But at the same time, I would like you to sort of remember what's happening with this whole thing. So here we go. Simplifying rational expressions by using opposite binomials. So as we can see, we have a situation here. In this situation, the numerator and the denominator are opposite binomials. X minus 3 is opposite of 3 minus x. Essentially, these numbers and variables have switched places. So we could rewrite this 3 minus x as negative x plus 3. You can always write an addition problem, because we could also rewrite this as saying 3 plus a negative x. You can always rewrite an addition problem as in whatever form you want to. You can use the commutative property to move terms around. So the negative x comes out in front and the 3 goes in back, and we add that addition sign. So if we write it like that, what's kind of cool is if we want to make that x then positive, we could factor out of both of these terms, the negative x and the positive 3, a negative 1 from that. And if we factor out that negative 1, we have then x minus 3, because a negative has been factored out of the x and that positive 3, so the positive 3 becomes a negative 3. And if we notice now, we have x minus 3 over x minus 3. So to finish all of this up along the top, what we can say then is the top can simplify with the bottom. So it's essentially dividing by 1. We're dividing by x minus 3 on the top and x minus 3 on the bottom. So we end up with a positive 1 on the top, and we end up with a negative 1 remaining on the bottom. 1 over negative 1 simplifies to a negative 1. So now let's consider this whole concept of using opposite binomials to play around with a problem. We have this problem right here where it is 2x minus 10 over 25 minus x squared. So first things first, we're following our steps that we learned at the beginning of this chapter. We first need to find all the factors that are not going to work for our denominator. What are our excluded values? We have 25 minus x squared. We're going to set that equal to 0. 25 minus x squared, we can rewrite that as 5 minus x and 5 plus x and set that equal to 0. So 5 minus x, 5 plus x, so x could equal a negative 5 or a positive 5. So we're going to hold that in our back pocket for later. That's going to be part of our answer. After that, we need to actually say, all right, we need to finish factoring. So we've factored the bottom as 5 minus x and 5 plus x. And on the top here, we can factor that, and it looks like there's a 2 in both of these. So we could factor out a 2, and then after that we have x minus 5. So when I'm looking at this, I see opposite binomials. My opposite binomials are this x minus 5 and the 5 minus x. Those are opposite binomials. And I know from this little step right up here, I could write, essentially before the 3 minus x, I could rewrite that as saying it is negative 1 times x minus 3. So I'm going to do that step down here with this 5 minus x. So we have our 2 up in front on top, and we have our x minus 5 on top. And now we need to rewrite this 5 minus x as essentially x minus 5. So we're going to write it as negative 1 times x minus 5. That's all we need to do. We also have our 5 plus x left over. So now we just need to finish our simplification process. We just need to find the one that we can divide out. So our one that we can divide out, I see an x minus 5 on the top and an x minus 5 on the bottom. So those essentially disappear. And on the top, I'm left with a 2. On the bottom, we have a negative 1 times 5 plus x. To make this a little bit easier to look at, I'm going to bring that negative 1 out in front, and I'm just going to simply write everything as 2 over 5 plus x, and we have our negative out in front. So there's our final answer, where x cannot equal a negative 5 or a positive 5. And there's our final answer. So our final answer, negative 2 divided by 5 plus x, where x cannot equal a negative 5 or a positive 5. So let's try this again with another problem. We have 2 minus 2m over 2m squared plus 2m minus 4. First things first, let's identify our excluded values. So we have this 2m squared plus 2m minus 4. We need to set all of that equal to 0. So let's factor a little bit. Factoring could mean taking out a GCF, so I'm going to take out a 2 from every term because there's a 2 in each term, or as a factor of each term. So we have m squared plus m minus 2 is equal to 0. After that, we need to continue to factor. So m minus 1 times m plus 2 are my numbers that I could factor this polynomial into. You could also do bottoms up and see if you can find it that way. So bottoms up would look something like this. What two numbers are factors of 2? We have 2 and 1 as our only two factors, and we have a positive m, so our negative is going to go with our 1. So we found our factors. That means we can also do a little bit of math. That means m cannot equal 1 or negative 2, so we're going to add that into our final answer when we finish it all up. So let's now take our factoring situation and rewrite our equation. We have 2 minus 2m on the top over, I'm going to write this in a new color, I'm going to write all of this in blue. We have 2 times m minus 1 times m plus 2. So we need to finish up a little bit of factoring. I know that you can already see that we have a 2 and a 2 as factors in our top equation, so we need to factor out a 2 on top, and we'll end up with 1 minus m after that, over 2 times m minus 1 times m plus 2. One last little step, we have that funky little thing with opposite binomials. So here are our opposite binomials. I'm actually going to play around with this top binomial a little bit because it's just kind of easier to get to. So we still have our 2 up in front. We're going to rewrite this binomial right here as multiplied by a negative 1, and then we have m minus 1. So we've now written our opposite binomial like it is written in the denominator. So then we have 2 times m minus 1 in the denominator times m plus 2. After that, we just need to get rid of all of our extra stuff, all the extra fluff. If we have something on the bottom, we need to take care of it if it matches something on the top. So m minus 1 is on the top and the bottom, and we have a 2 on the top and the bottom. So we can rewrite all of this as a negative 1 on the top over everything that's left on the bottom is m plus 2. Negative 1 over m plus 2, where m cannot equal 1 or a negative 2. Final answer. So play around with this concept of opposite binomials. I hope it'll help you both on Chapter 8 and Chapter 12 parts of our test. Please be sure to ask questions, text, email, ask questions during class, after class, before class, at lunch, all that jazz. So I hope to see you later, and I hope this helps. Bye.